Here's an example of a problem where the zeros are exactly what we're after, and it's going to tell us something about this physical situation. In this problem, f of t equals negative 16t squared plus s, and we say this is like sub-zero or s naught or s0. This represents the height in feet of a falling object t seconds after it's dropped from some initial height s sub-zero. So this, whatever this number is how high up the building is, and t is how much time has gone by while this falling object is falling. And it looks like someone stands on the top of this building and drops an egg off the top, because I assume because they're very bored and want to entertain themselves. But the top of this building happens to be 64 feet. So since the height of the building is 64, that's exactly what this S naught is representing. The question is, after how many seconds does the egg hit the ground? Well, this function represents how high up the egg is. So if we think of, just as like a sketch, whatever this function is, I think that t is the input, and then this height would be the output. And where it makes sense for where would I look on this graph to see where the egg hits the ground? Well, the ground is no feet off the ground. So I think this is telling us that we need to figure out where would whatever this graph looks like, we need to figure out where does it cross the x-axis, or another way to say it is what input makes the output 0, or what are the zeros of this function. So let's write down what the function is. We'll use our Desmos to graph it, and we'll use that to interpret that to answer this question. The only thing we really need to know is what the initial height of the building is, and we already figured that out. So I think a rule that represents this function would be f of t is equal to negative 16t squared plus 64 feet. When you're using a graphing calculator Desmos, we're going to change all the inputs to x's because it deals with that better. Over here, we'll type minus 16 squared plus 64. Here's the graph. If we want to zoom out, we can see the whole thing. That's not really that important because the only thing that we really care about are the zeros, and there happens to be two of them. The zeros, Desmos will find these zeros, we just click on them. They happen to be negative 2 and positive 2. So after how many seconds does the egg hit the ground? It's at height 0 after 2 seconds. Note it could be at height 0 after negative 2 seconds, but negative 2 doesn't really make any sense in the context of this problem. So I think t equals 2 seconds when it hits. The second part of this question asks, suppose we adjust the initial height by k feet. Either we maybe go down a few stories, or maybe we find a taller building than 64 feet. How will that change this answer in part A? So what if we add or subtract something to this? Maybe instead of 64 feet, we have a smaller number or a bigger number. And I hope the answer is intuitive, but maybe we'll use Desmos to check, to give us some estimates here. Let's say I take my original equation and I keep it the same. I'll do minus 16x squared. But instead of adding 64, maybe I make case a negative. I make it smaller. So how about instead of 64, how about a smaller number, how about 50 instead? So if instead of adding 64 I had 50, or a smaller number, or I go down by, looks like 14 feet, then what does that do to the zeros? Well, it clearly brings them in. And if you zoom out, you can kind of see that, like this new function is kind of is slid down, so it's always inside, so it'll never be quite as wide as the original function after the same amount of time has gone by. So I think one way to interpret this is that when k is smaller, that makes the zeros smaller, which means it's going to hit the ground sooner. So when k is a negative number, or when the initial height is not as high, when the initial height is not as high, that corresponds to when k is negative. It hits the ground, the egg will hit the ground sooner. I hope that matches what you've known, what you've would hope for in reality. Egg hits the ground sooner because the zeros are smaller. And conversely, if we come back to a graph and instead of a number smaller than 64, we pick a number bigger than 64. How about we'll go up a bunch. How about go up like to 81? It now looks like our zeros are farther out, meaning it's going to take longer to hit the ground. So when k is positive, it takes longer to hit the ground. And that should make sense because the egg starts higher up when k is positive. Because k is how much we're adding to the height.